Hello, my name is ZhaoyanLi. This is my final report about system engineering, and today I will talk about something about Boeing 737 MAX. And today I want to split the content into 7 parts. The the first, second, third, and the fourth part is about the midterm, and the 5, 6, 7 is about the final term report. And first, I will introduce the system engineering definition and the background of Boeing 737, and I will talk about something about the concept development stage and the challenges in Boeing 737. And the 5, 6, 7 is about the final report, and it's about the engineering development stage, post-development stage about production and operation, and the summary about the all the course and the thoughts about myself. And first, let me introduce the system engineering definition. And system engineering is an interdisciplinary approach and means to enable the realization of the successful systems. The definition of a system is inherently applicable to different levels of aggregation of complexity and interacting elements. Every system may be regarded to be a subsystem of a higher level system, and every subsystem may itself be considered as a system. So it's complex and it can be seen as a whole. And in system engineering, there are 3 entities that we need to focus: information, material, and energy. And information means the contents of all knowledge and the communications. And the material is about the substance of all the physical objects. And the last part, energy, which energizes the operation and movement of all active system components. And also, we need to focus the 3 criteria: the significance, which means that each functional element must perform a distinct and significant functions, because this can make the marked profit. And the second is the singularity, and for keeping your products very special and everyone will need it or not replaced by others, we need to focus the singularity. Each functional element should fall largely within the technical scope of the single engineering discipline. And the third one is the commonality. The function performed by each element can be found in a wide variety of system types. And the system engineering we are willing to split our systems to different levels: system, subsystem, components, subcomponents, and the parts. And this is the levels from the bigger one to smaller one. And the term system that is commonly used does not correspond to a specific level of complexity. Systems may serve as parts of the supersystems, and subsystems may themselves be thought of as systems. And the background of a Boeing 737, the background of a plane, background of Boeing 737, background of Boeing 737 MAX. Accidents of the Boeing 737 MAX is our content of the second part. And this is the background of the plane. The Wright brothers, famous all around the world, had a lot of problems when they started designing airplanes. The first consideration is how to lift the aircraft. how to generate a huge lift to make the aircraft fly successfully. Second, how to control the direction of the plane in the air. This is important. Third, how to make the aircraft resist strong winds and reduce damage. And the whole things we need to concern about the material structure and the pilots themselves. And in the concept development stage about the Boeing 737, and our need analysis is this plane need to carry 100 people, and the range of it, and the maximum commercial load factor, and the common parts as possible, because this can save our cost. Also, we need to talk about the Boeing 737 MAX. It's developed based on the Boeing 737. It depends on the idea. We need to accommodate more passengers. Secondly, it needs to improve the efficiency of the airplane flight because they want to save more resources and the oil and the fuel. And also, and now we need to talk something about the concept exploration. In this phase, they need to explore the best way to achieve the aim. In the Boeing 737 MAX, they explored the way like changing the styles of the wings and increasing engines. In Boeing 737 MAX, they decide way about using more advanced engineer because save more fuels and change the designation of the inside decorations because they need to give the passengers more comfortable ways to sit inside. They want more passengers to choose their flight, so they need the performance of the engines and the structure of the wings. They need to change it. Now we want to talk about some problems. The Boeing 737 MAX demands analysis is that it expanding the cabin to accommodate more passengers. You need to accommodate more passengers. You need to focus the three parts. And I think many manufacturers will focus the three parts, like a car, like a plane, like train. They need to focus on this: the materials, the structure, and the maintenance. And these three things we will set after this part in the engineering development part and in the production part. We all will discuss about. And now we talk about some challenges they face. Why Boeing 737 MAX faced a lot of the problems. First, they have less of surveillance. During their annual inspection, I saw news about that. The engineers saw these problems. They know that there is not enough oil to smooth these equipments inside of the plane, but no one to fix it because they think it's a small problem. It will not cost much. However, in fact, it caused the Boeing 737 MAX the Lion Air. The accidents famous around the world. It's a huge accident. Some engineering has spotted the problems, but it was covered up. The Second, we need to talk about is the material maintenance. For many high precision, large equipment and instruments, maintenance and repair is a large cost, especially for the big systems like the plane. And everything inside of the plane need to fix, need to check. But this is the normal procedures for the engineering because checking can keep the plane fly safe. In Boeing 737 MAX design, maintaining such a large part was a huge challenge. According to the news, the Boeing 737 MAX may cause a serious wear of the parts due to insufficient lubricating oil. Besides the regulatory issues discussed before, the parts themselves are not well protected. Also, for the maintenance, in the designation part, the engineers need to consider about the cost and the effectiveness when it comes to maintenance. They need to consider about the trade-off problems. These two needs to be designed and determined during the conceptual exploration phase. Where maintenance costs need to be judged if the components with a high performance are vulnerable to damage. And we talk something about a fix. For many high precision large equipment and instruments, such as our plane, maintenance and repair is a large cost. In Boeing 737 MAX design, maintaining such a large part was a huge challenge. According to the news, the Boeing 737 MAX may cause serious wear parts due to insufficient lubricating oil, we have mentioned before. Besides this, these parts are not well protected. And now we are going into the fifth part, the engineering development part. And this part we will talk something about the manufacture of the plane and the Boeing 737 MAX. And we will analyze the risk of this plane. Why cause these huge accidents? We have mentioned something before, like the lubricating oil, but we will not analyze the structure of the plane and why they're easy to get this problem. And in the third part, we will discuss something about the balance, cost, and the profit. First, we need to see something about the definitions. In the engineering development part, we need to analyze the risk and the uncertainty of the systems. It's not our job, it's the engineer's job. Moreover, it's time to validate the system design because we design the whole definitions in the concept development part in the last part. But we don't know whether it is fit for our systems. We don't know that if we met some problems we don't think before. So we need many ways to detect and test it on different subcomponents, components, parts. We need to focus the performance and we need to focus at the quantitative results. Also, we need to consider the whole system for full-scale engineering. So it is more complicated than the concept development part. We need more engineers to operate it and to build the model to test and update each subcomponent. And in the advanced development part, this is first part about the engineering development. This phase is time to confirm the risks and uncertainties in advance. and the engineers need to validate the whole systems and decrease the risks if they find in this phase. Now we take unproven concepts to uncertainties because each unproven concept cannot see the risks clearly. What's the difficulty in this part is how to ensure the risks will not cause future damage in working time. So the engineers need to spend time making specification and build the model. The model is really important in all the systems to avoid risks in the future. And for Boeing 737 MAX risks, after enlarging the body of the plane to accommodate more people, we have mentioned before, engineers need more power to make huge lift. So they choose a bigger and more efficient CFM LEAP 1B engine. Engine is a new type. It's a really new type. And in the results, we can see that it's very perfect. It saves a lot of fuels and it can give more efficient lift. But for a new type, it is without detailed test. Also, for accommodate the new type of the engine, the engineers want to choose a new winglets. It is designed to reduce drag. The wings look smaller compared with the huge engines, and it has very special designation about the shape. Now we come back to the definitions. How to validate? There are two ways: prototype development and the development testing. In the prototype development, they can decrease the risks and the deficiency. Sorry. In this way, they can develop the new equipments or components to get better efficiency and effectiveness. In development testing, they first need to make the standards of plane. Only reaching the standards it can pass the development testing. Okay, let me talk about the updates about the Boeing 737 MAX. For the winglet, it has a special design. The new 737 MAX at 80 winglet is the most efficient ever designed for a production airplane. With the original blended winglet design, the airflow at this tip is used to create lift on the winglet. You can see in the left picture. Primarily factoried towards the fuselage, there is also a small element of the lift factoried forward, reducing the lift-induced drag. In addition to the inward, upward, you can see the upward part and the slide forward lift components of the upper airfoil. The new lower airfoil generates a vertical lift component that is vertebrate away from the fuselage and also slightly forward. Working together, these provide the perfect balanced winglet that maximizes the overall efficiency of the wings. Now let's talk about the engines. The engines we said about it is a new type that no other plane used it. Speaking of the engines, LEAP 1B, which is the new generation engines, will set the standards in terms of efficiency and the total cost of the ownership. The new engine LEAP 1B has advantages such as lower fuel consumption rate, lower carbon and nitrogen emissions, things like the good for our environments and the atmosphere. Low, lower noise and because it is more comfortable for the passengers sitting inside, and the high reliability. And the high reliability is about the test results of the single engines. It is said about said by the the CEO of the Lib 1-bit CFC company. So when we talk about this, we will need to doubt about the reliability of these things. But also you can see that this causes accidents in the plane. Now let's go into the failure part. We know that in system engineering, engineers need to count the mean time between failures, which means that it can be used to represent the reliability for each component and an appropriate combination of the MTBFS is the mean time between failures reflect the system reliability. And these things can help us to find that whether this components is work rightly. So I think that Boeing 737 MAX cause accidents have some problems in these parts because testing is not complicated in this style of plane. Another thing we need to discuss is about the redundancy. These things means that it's related to the independence of the whole system. That is means that if the whole system doesn't work, then whether these components can work. You know, in the plane, I have seen a series about the plane accidents. The pilot says that if the other systems is wrong, but if one system is wrong, other system work normally, that they can keep normal work. So one system, one components is wrong cannot have a bad influence on the others. This is the principle. A significant critical of the redundancy lies in the observation that many calculations assume that redundant systems behave completely independently of each other. So we need more redundant systems in our system. For Boeing 737 MAX, we need to have some doubts about the independence of redundant systems since it caused two disastrous accidents in a short time. So for Boeing 737, if I am the engineers of this company, I will test all the subcomponents, all the parts of it to make sure that everything runs good in flight. Design diversity is the practice of designing redundant components differently while still keeping their function the same. And for our engineers, they need to know how to find the reasons. First, they need to understand the power of the new flight control systems, the MCAS systems, and this system is very new in the plane history. The control system is to wheel with the horizontal tail to abort. And some news says that the Boeing 737 MAX have some problems on the abort. When the plane enters service, the MCAS can move the tail far more than 4 times than before, and this is the theory. Second, they analyze the action and the movement of the pilot. Every action and the decision of pilots can make huge influence on the plane, but the plane have large change and the system cannot reset itself when a pilot responded, which has a potential impact to system, repeatedly pushing the airplane's nose downwards. Experts cannot explain this point. It may cause trouble in it. Third, every plane has a black box. Black box shows the design diversity, which is a practice of designing redundant components differently while keeping their function the same. Producing interchangeable black boxes with the different contents. So analyzing the black box can help us understand the failure of our plane. And now let's go into the integration and the evaluation. This part is the optional phase in the engineering development. If the system is perfectly engineered, it is not needed. But how to know whether the system is perfectly engineered or not is very difficult. So most of the systems need this phase to validate the safety and the completeness of any system designs or specification. However, this phase is also very difficult to test, since hundreds of tests of thorough individual components only show the probabilities, which means that it exists a potential damage or danger. Also, except the components, it exists the danger when they combine together. When we bring it together, we need to do more performance tests. For the aircraft requires the structure testing, fatigue testing, durable testing, load calibration testing, landing gear testing, and hydraulic system testing, and so on. And these things can cover all of the possible situations in the flight. And how to do the test on several single components. The LEAP engine performed incredibly well throughout the extremely rigorous ground and flight test. They do the icing test, the low temperature, and the flocking inhalation test, and the large bird inhalation test, and the fan blend extrusion test, and so on. And this test simulate the environment in the plane. And in the sixth part, we will talk something about the production and the transition. Only if this system put into production, it can make profit in the market, and this is our aim. Every system needs to make the market value. Except production, they need to concern about the transition, storage, and fix. The transition is the most important part in it. For some expensive and fragile system, it costs much. So when we produce the fragile system, we need to consider the transition fee. The place of the factory need reconsider in this situation. As for Boeing headquartered in Chicago, Illinois, and it has a high share of the aviation industry and is a global leader. But the Boeing factories are located in Kansas, the sun state in the middle part of the America. Nowadays, on the basis of the economic globalization, Boeing has many factories all over the world. It borrows the technical and the human resources from various countries. And now we talk about challenges. The challenges for making an airplane is also concerned about the three parts we discussed before. The material. First is material. The materials is really important because they depend on the technique. It needs to optimize the structure. Materials it can make the materials more stable and more efficient. Also, it depends on the simulations because we need the simulations test area. So this part depends on the modern computer materials simulation and the analysis technique. We need the computer to give us a result and to select the optimal structure. Summary part. In this course, I have learned much knowledge. I have the whole idea and viewpoints of the system engineering. First is the concept development part. It allows the engineers to validate all the definitions which will possibly be used in the engineering process. Second, I have a comprehensive understanding of engineering development stage. This stage is about engineering work, so there are many difficulties will be met there. Moreover, by writing the report, I have known the history, invention procedure, background, production, and the current situation of the plane from Wright brothers and from Boeing 737, and I know some facts of the Boeing 737 MAX accidents. Thanks for the teacher. Thanks for your listening. Thank you. My name is ZhaoyanLi.